Okay, so this block is sliding to the right. That's what those little dashes mean there, right? Okay, and it's accelerating to the right at 4.5 meters per second squared. Okay, so the acceleration is this way. So what force is needed? Well, if it's sliding, the static friction is no longer relevant. It's broken those little weak molecular bonds with the surface. And this is the force that we need to deal with, right? The kinetic force. It's moving. Kinetic just means moving. Okay, so I'm going to say that there's a force of friction to the left, okay, of 15.68. I know that because if it's sliding to the right, friction is the other way. Okay, and then I'm going to say that there's some unknown force. Now, we both know it's to the right, but we'll let the math show us that, right? So here is some unknown force like that, right? Now we solve this just like a net force problem. Let's make this the positive direction, this the negative direction. That makes that a negative force, this a positive force. Now, keep in mind that I make all unknown forces, I make them all positive. I think it works best that way. So now we set up F equals ma. So we have negative 15.68 plus F equals 5 times, and now we have to decide, is this acceleration, is it positive or negative? Well, it's accelerating to the right and sliding to the right. So if this is negative, the acceleration must be positive, right? Okay. And now we're all set. We're just gonna, the force will actually be ma plus the force of friction. Okay, so let's calculate that. Okay, 5 times 4.5 plus 15.68, 38.18. Ta-da! That's the answer I've got down there too. So that's all good and happy. So basically the gist of this, the algorithm for solving these friction problems is step 1, find the force of friction. Okay, force of friction on a level surface is mu times m times g. And we're never going to go away from a level surface, okay? Step 2, solve the net force problem. Okay? Set up, usually it's a force minus the force of friction equals m times a, right? Alrighty.